Welcome to July 15th LeetCode challenge. Valid triangle number. Given an integer array nums, return the number of triplets chosen from the array that can make triangles if you take them as side lengths of a triangle. Alright, so you're given an array 2, 2, 3, 4. So how many, what's the number of triplets you can make? What is the number of triplets chosen from the array that you can make a triangle with? So you have three options in order to make a triangle. So you can either choose number 2, 3, 4 from the first two to make a triangle, or the second two to make a triangle, or 2, 2, 3 to make a triangle. Now, how does this kind of work here? So if you use something called the triangle inequality theorem, which states that the sum of the length of any two sides of a triangle is greater than the length of the third side. So let me write this out for you guys. So if we have a triangle, say the sides are A, B, and C. This is the perimeter of the triangle, let's say. So we know that the sum of the two sides of the triangle is greater than the third side of the triangle. So for instance, A plus B is always going to be greater than C. A plus C is always going to be greater than B. And B plus C is always going to be greater than A. So this is known as the triangle inequality theorem. It's found in geometry and basic mathematics here. So we're going to use this idea to help us solve this problem. So in a triangle, the length of any sides is less than the sum of the other two sides. So we have three sides, A, B, C. Let's say, for example, we can form a triangle if these conditions are true. And this is known as triangle inequality theorem. So let's make it a little bit easier on ourselves. And first thing we're going to do is probably sort our array. Because we're given an array here, it's nums, right? It might not always be sorted. So from that array, what we're going to do is create two pointers, and we're going to do a linear scan on the array in order to figure out what are the valid options we could do. So we're going to have let's say we're going to have being a index I, so nums at index I being the smallest number, and then what we're going to do is we're also going to have nums at index j being our mid number. And then we have another pointer here, index k being our largest number. So we're gonna have three pointers here, and we're gonna move the j and k pointers for each I element, and in order to do a linear scan. So we know that, for instance, num at index I, num at index j, num at index k, this will represent our ABCs here. And then a triangle, it can only form a valid triangle if, for example, we have we'll use the triangle inequality here. So num at index I plus the num at index j is greater than num at index k. So if this is true, then there are j minus I pairs that we can make, because I is increasing the inequality is always moving upwards. And then once we have this done, it means it's a valid pair. And also we're gonna try another j term by decreasing j by 1, so that we can move on to the next one. Else, if this is not true, then we know that this is true. That means that we could not make a because k is a fixed term, therefore we make the inequality correct. So the only way is to increase the sum of I and j in order so it can move along. So there's only one choice to increase, which is num I. So we're going to move that along. So pretty much, if in order to write this out, so let's do kind of like an if-then statement here, or if-else statement. So if the triangle inequality is true, this is like pseudocode, by the way, then what we're going to do is assign that this is j minus I valid pairs, and then we also have to try another num j. So that means we have to decrement it. Decrement by 1. Else, what we want to do is increment num j by having increase num at I via plus increment by 1 I, or I. Something like that, right? Alright, let's go about solving this. So we use a linear scan for to solve this and creating 3 pointers. So first thing we're going to do is sort the numbers. So nums.sort. Next thing we're going to do is have our find the length of our nums. And then we want to initialize our output being 0. So for k in ranges between 0 to 2, or 2 to n, I should say, what we're going to do is, so notice how it's 2 to n, because we have to iterate k through the ranges of 2 to n minus 1, because the answer is the total number of pairs between nums I and nums j, index I and index j. So first of all, I have to initialize them. J is going to be actually k minus 1. There you go. So now we have kind of our I, j, k parameters built out. So I'm going to do a while loop here. While I is less than j, a triangle inequality there. If nums at index I plus nums at index j is greater than nums at index k, what we're going to do is increment our output, because that is a valid solution, by 1, by j minus I solution, valid pairs I should say. And then decrement j, as we said before. Else I increment it by 1, because we want to move that pointer, right? The I pointer. And that's pretty much it. We want to return our output though. And let's see if this idea works. Three, submit. Accepted. Awesome. So let's see. Time complexity would be n squared. Yes, n squared. We have a for loop here, and we have to cycle through each ij, so while loop, and we have an if statement here, so it'll be yeah, n squared. Big O of n squared for where n is the size of 1000 at max, or the size of the nums array. Space complexity is big O of n log n, because we're using the num sort algorithm, and we're storing everything in input. So this is sorted already. Alright, that's it. Have a great day, guys.